Alright, welcome back to Mass Expert video tutorials. Very good. Now, in this video, we are going to look at co-functions identities. Co-functions identities. Now, you have to know that the trigonometric function of an acute angle is the same as the co-function of its complement. The co-function of its complement. Alright. What I mean is that when you verify the co-function identities for the acute angle using the complementary angle in a right triangle along with the right triangle base, okay, along with the right triangle base definition of the trigonometric function. Then, and when you're doing that, you have to emphasize that these identities apply to any angle theta, not just acute angle. The emphasizing is not just an acute angle, but can be applied to any angle theta. Alright, so these are the co-function identities that we have on the board. That when we have cos 90 minus theta, that will be the same as taking sine of the theta. That is the same as taking sine of the theta. And that is very good. Now, you have to bear in mind that we can derive similar identities by obtaining for a real number domain by replacing 90 degrees with pi on 2. We can replace 90 degrees by pi on 2. Very good. So that is that we have for that. Let's see some examples and see how we are going to get into it. Very good. Or before that, let's look at something. We know that cos A minus B is the same as cos A cos B plus sin A sin B. Now we are going to substitute 90 degrees for A, and I just want to prove one of it for you to get or to be able to grab the understanding well. Alright, it's not about achieving it's not about achieving everything, but you getting the understanding. So we are going to replace 90 degrees by A and theta for B and theta for B to see what you are going to get. So now put A to be equal to 90, B to be equal to theta. So cos A is going to be 90 degrees minus theta. Therefore, wherever you see A, put 90 there. Wherever you see B, put theta there. So we get cos 90 cos theta plus sine 90 sine theta. Very good. Now cos 90, you all know that cos 90 is 0. And once is 0, it's going to multiply cos theta here plus. You also know that sine 90 will be 1. Sine 90 is 1, and it's going to multiply sine theta. It's going to multiply sine theta. And the whole of here is 0 plus this one will be sine theta. So we end up by getting sine theta. So you see, it's coming from a right concept, alright? It's coming from a right concept. So that is how we prove for the second one. You can do the same thing for the second one, and that is what you get by quoting sign. Let me prove that one to you also. Oh, okay, let me allow you to do it yourself. So, what if we have sign A minus B? You see, sign A minus B is going to be sign A cos B, alright, plus the sign don't change, minus cos A sin B. Then we put A to be equal to 90 degrees and B to be equal to theta. So you can see that here we get sin 90 minus theta to be equal to sin 90 cos theta minus cos 90 times sin theta. Now, now we all know that sin 90 is 1 multiplied by cos theta minus cos 90 is 0 multiplied by sin theta. Therefore, everything here is 0. So we end up by getting cos 90 degrees. Alright, so we can do the same for all. And that is what that is where it's going to arrive you at. Very good. So these results is true for any value of theta, saying the identity for cos A minus B or sin A minus B is true for any values of A and B. Very good. So let's move on to solve the first example. All right. We are still looking at cofunctions, identities. Very good. Now, our first example, we have to find an angle, rather. Find. Okay, so let's quickly go for the first question. The first question, we have cos theta to be equal to tan 25. Alright. Now here we have cos and tan. So we are going to link these two to the cofunctions identities where we have cos and tan. And that is going to be tan negative minus theta to, which is equal to cos theta. Don't forget that we have defined an angle theta that satisfies each of the following. We have defined an angle theta that satisfies each of the following. Very good. So let's go for that. So now, if this is equal to this, then we can say that this is equal to this and cos theta is equal to 25 times 25. Therefore, we can say that tan 90 degrees minus theta is going to be equal to tan 25. Alright, very good. Now, here we have tan on both left and right. I haven't teach you tan inverse. So, sorry, I haven't teach you inverse function, so I don't want to go there. Alright, so when you get something like this, what you do is that you multiply both sides by tan inverse to clear off the tan. You multiply both sides by tan inverse to clear off the tan. Alright, so you multiply this by tan inverse, this by tan inverse. Tan inverse times tan is going to give you 1. Alright, or let me say it's going to give you the angle. Let's say tan inverse of s times tan inverse of s times tan s. You're going to get the argument, which is what? X. Very good. So we'll be doing that in our subsequent video. So here you are going to multiply both sides. Multiply both sides by tan inverse. Okay. So when you multiply both sides by tan inverse, you are going to get 90 degrees minus theta, which is equal to, because when you multiply here by tan inverse, you will be left with the argument, which is 90 minus theta. When you multiply this by tan inverse, it will be left with the argument, which is 25. In another way, you can say that let's divide both sides by 10 so that it will clear up. Alright. Because we haven't done tan inverse, so maybe you're not getting this. If you're not getting this, just multiply both sides by 10 and you go your way. Now to get theta, because we are looking for theta, that will satisfy. So here we get 90 is equal to 25 plus theta. And we get theta to be equal to 90 minus 25. Very good. And theta is going to be 65 degrees. 65 degrees. Nice. So we get theta to be equal to 65 degrees. So this means that for theta to be 65 degrees, it satisfies tan cos theta is equal to tan 25. What this means is that when you pick your calculator and you press cos, you know, on calculator you are not going to get cos theta or you are not going to get cos theta or anything, no problem. When you replace here, you know that 1 over tan is the same as cos, so you tan. Sorry, cos, so you can do that. When you replace theta here, the value you get will be the same value that you're going to get here, and that is what we are talking about here. Very good. Let's move on to the second question. So that's how we solve that. In case you are to find for the angle. The B is cosec 3 pi over 4 is equal to sec theta. Very good. Cosec, sorry, let's go for the B. Let's rather the C. Sin theta is equal to cos negative 30. Very good. So now, sine and cos, which of the cofunctions identities that sine and cos is going to be, that sine and cos going to be related? I think that's the first one, right? And the first one says that cos, the first one says that cos 90 minus theta is equal to sin theta. So you see, always focus on where the angle is, the argument is given, not this side. Alright? Okay, not this side. So you can see that with this, we can say that cos 90 minus theta is equal to sin theta. Therefore, cos 90 minus theta is equal to cos negative theta. Alright? It's equal to cos negative theta. Because if this is equal to this, which is an identity, then this is equal to that. Very good. So for us to find for the argument, for us to find for theta, we multiply both sides by cos inverse. We multiply both sides by cos inverse. And it will be left with the, or we divide both sides by cos, and it will be left with 90 minus theta to be equal to negative theta. So 90 is equal to negative theta plus theta. Therefore, theta is equal to 90 plus 30. And finally, we get 120 degrees. So, for theta to be equal to 120 degrees, it's going to satisfy that is going to satisfy that. What it means is that when you on your calculator, when you place cos 120 degrees, the value is going to be the same as cos 90 negative negative 30. Very good. So that's how we do that. All right, looking at the C, the argument is not in an angle form, but rather the radian form. Therefore, we need to change the from the identities. We need to change the 90 degrees to radian, and that is going to be pi on 2. Very good. So let's go for that. We have cosec 3 pi on 4 to be equal to sec theta. All right. So cosec and sec, both cosec and sec are related to one of the identity. And that is going to be cosec. Now we are not going to write 90, but rather pi on 2 minus theta is equal to sec theta. So if this is equal to this, then cosec pi on 2 minus theta is going to be equal to cosec 3 pi on 4. So you divide both sides by cosec and you get pi over 2 minus theta to be equal to 3 pi over 4. So theta will be equal to pi over 2 minus 3 pi over 4. Alright, very good. So theta, what is theta? And when you do that, you are going to get theta to be negative pi on 4. Negative pi over 4. Very good. And when you get negative pi over 4. So that is going to be for theta. That will satisfy this equation. Very good, very good. Now, you have to take note that because trigonometric or circular functions are periodic, the solution in the second example, that is the solution in these are not unique. The solution in A, B, and C, they are not going to be unique. We give only one of the infinitely many possibilities. All right. So that's the only thing that you need to take note here. Let's move to the third question. Now, what if one of the angle A or B in the identity for cos A plus B and cos A minus B is a quadrantal angle? All right. Then the identity allows us to write the expression. Then the identity is going to allow us to write the expression in terms of a single function of A or B. How do we do that? All right. Let's go for the third question and see how such is going to be related. So let's go for that. So example 3. And that is reducing cos A minus B to a function of a single variable. The example 3 is reducing reducing cos A minus B to a function of a single variable. Alright, so let's look at that question. Write cos example 3. Write cos 180 minus as a trigonometric function as a trigonometric function of theta. As a trigonometric function of theta. Very good. Now, when we are given this question to write as a trigonometric function of theta, what we do is that we are going to use the difference identity. That's, you are going to replace A with 180 degrees and B with theta. Bear in mind that the one that we did in the second example, was negative minus theta, but this is 180 minus theta, so they are not the same, right? So the identity for 180 minus theta is going to be different from negative minus theta. That's why this is reducing cos A minus B to a function of a single variable. Alright, so here we know that cos A minus B is cos A cos B plus sin A sin B. Very good. So you put A to be 180 degrees and B to be cos theta. So cos 180 cos theta plus sin 180 sin theta. Let's move on. Now, we know that cos 180 is negative 1 times cos theta plus sin 180 is going to give you 0. Sin 180 is 0 times sin theta. So the whole of this is 0. So this multiply this, you get negative cos theta plus 0. So what is, therefore, we conclude that cos 180 degrees minus theta is going to be the same as negative cos theta. Alright, so we conclude that this is going to be that. Very nice. Alright. We can also do the same for the others, okay? We can do the same for the others. You can try on cos 180 sin 180 minus theta and see what that is also going to be. Very good. Thank you and see you in the next video. In the next video, we are going to look at sum and difference identity for sine and tangent. Don't forget, we have first looked at some and different identities for cosine. All right, and when I was about to end, I introduced that for the sign for you. So let's come back in the next video to use this idea in cofunction identity to prove the sign of some and different identity and the one for tangent for you. Thank you and see you in that video.